Do you remember which one we ended on? It seemed like it was 21, but
21, so we're on 22.
so we're going to start 22. All right. This is the math team meeting, and we're starting with a question from the competition, question 22.
All right,
Waiting
so
for it to pull. Okay.
it says evaluate the definite integral
Okay.
from 0 to pi thirds,
Pi thirds.
right, of secant to the fifth x,
Dx.
tangent x,
Second.
tangent x,
Tangent x
dx.
dx. All right. How would you proceed?
I know that secant can be rewritten as was it? Because secant to the fifth would be like secant squared
Right.
times secant squared
Right. Times secant.
times secant.
Right.
And you can rewrite secant squared as 1 plus tangent squared.
Okay.
Right?
Yeah, you can. And that's not a bad way to go. But in this case, I think there's an easier way.
Substitution.
Substitution. Let's try that first.
You
Okay.
see how much work I did on this test?
Right. So let u equal what?
Secant to the fifth x?
No.
No? Secant x?
Secant x. That's what I would say. Then du.
Is 1 plus tangent x?
No,
No, it's not.
what's the derivative of secant x?
Wait, let's see. Secant. Would be negative cosecant? Or no, it's weird.
Yeah, it is a weird one.
I always have trouble with secant.
Okay. Here's one way to do it. Write it as
1 over cosine.
1 over cosine x, or make that cosine x to the minus 1, and then take the derivative of that. What do you get?
That would be negative sine.
Okay, wait just a second. Okay. That would be negative.
Sine.
Okay. Wouldn't that be cosine x to the minus 2? And, oh, yeah, and then times. Okay, derivative of cosine is minus sine.
Yeah.
Okay.
That's where I started.
Oh, that's what you were saying. Okay, okay. You do your, okay.
I was like, what's going on?
Okay, got it. Okay.
So negative sine times a negative cosine to the negative 2x.
Right.
Gives you a-
Or you could write this as sine x over cosine x times 1 over cosine x, right?
Right.
And what's that?
The right one is, or well, the left one is tangent,
Okay.
and then the right one is secant.
You got it. The derivative of secant x is secant x tangent x, or tangent x secant x, doesn't matter, dx. Okay?
Oh, this is still du.
That's your du. That was getting your du. Can I erase this, or you want that left?
You can erase it.
Okay, just because it's sort of getting in the way of the problem, but it's a way to do it. Okay, okay. If you forget that one. And you'll usually not forget it more than a few times, and you say, I'm tired of doing this, so I'm going to remember it. Whether you actually think that or not, after you do it a few times, I think it nails it. Okay. Then what?
Okay, then, let's see. Alright, we plug that in, right?
Okay.
Well, let's see.
Let me rewrite this slightly as secant fourth x secant x tangent x dx.
That way you can plug it in.
Right. Now it's easier to plug in. What would that be? u to the fourth du. Okay. Now, we didn't change our limits. Let's see if we can do those without too much problem. When x is 0,
Oh, you got to change.
yeah, when x is 0,
Tangent is.
wait, don't do tangent, okay.
You're
You're u and x, right?
Right. So that'd be
But we can also do this x, because I find that easier to do.
That's what I was doing.
So x equals 0, what is cosine x?
It'd be 1.
1, and 1 over 1 is 1, so that's going to be 1. When x is pi thirds, what is cosine of pi thirds?
First quadrant. It would be 1/2. No.
No, you got it.
It would.
Yeah, 1/2, but this is 1 over 1/2,
So 2.
2. Okay, it's going from 1 to 2. Okay, and what would this be? Huh?
That's at least it's not going far. It'd be 4u to the third. No. This is not a third. That would be u to the fifth over 5.
U to the fifth over 5, a value from 1 to 2, so that would be
What's 1/5?
second. Yeah, the bottom is 1/5. You're doing the easy one. Okay.
And then the first part is 2 to the 5th, which is 32.
32 fifths.
And that'd be 31 fifths.
Was that an option?
This was number 22. 31 fifths is what they got.
Okay, good deal. They got it right. Good for them.
Let me pause for a second.
Okay,
I gotta call my grandma.
okay. I'll pause here too then.
He's going to figure slides.
Did you have everything off this one you needed?
Yes.
Okay. Okay, 23.
What values for x does f of x equal x to the 5th over 5 minus 4x to the 3rd?
Okay, wait just a second. I'm behind. Minus 4x to the 3rd.
Right. Over 3 minus 11x. You know, does that have a slope of 10? What values of x makes that have a slope of 10?
Okay. So what were we looking for?
What values of x
Right,
give you the slope of 10?
right, for that function. So what are we looking for then? What would, yeah, take a derivative. F prime of x is equal to,
That would be x to the 4th minus 12.
uh,
No, okay, 4x squared minus 11.
okay, and what do we want to set that to?
10.
Okay,
No.
wait, no, that is a derivative. It's not where it's 0, it's where it's equal to what, 10?
Yeah,
Oh.
what x's are equal, make that equal to 10.
Okay, you ought to then set that equal to 10, yeah. Okay.
Okay.
Yeah. Whoa! It just went wacko on me. Okay. Alright. So then this would be x fourth minus 4x squared. What?
Oh, equals 22 or 21. Excuse me.
Minus 21.
You're making it equal to
0.
That helps for factoring purposes.
Yes. I'm hoping so anyway. I believe it might. That would be
X squared
x squared
and x squared.
times x squared.
Okay. 3 and 7, -7 positive 3.
That looks right.
Yeah.
And I assume we're dealing with real numbers? Okay.
Well, let's say yes.
Okay.
All right, so
If we're using complex numbers, there's 4, and
it'd
if
be,
it's
it'd be the square root of positive and negative 7 and the square root of positive and negative 3, right?
okay. Pretty close to that. X equal plus or minus the square root of 7.
That's what I
Okay.
I was saying it weird.
Right, and this would have been x equal plus or minus the square root of negative 3, which would be plus or minus I root 3. Now, if you're using complex numbers, there's 4 solutions. If you're using real numbers, it's just 2.
So there's no answers with I in it, so would it? It's just the plus or minus
7.
root 7.
Root 7, yeah. And that, is that one of the answers?
That is the.
That's the answer. Good deal. Okay. I couldn't remember how it was worded, if it would have included complex numbers or not. Okay. Enough of that, or 24.
Alright, oh, this is the fun one.
Okay.
Evaluate the integral below.
Okay.
The integral from 0 to 1
0 to 1.
of the integral from x to x squared.
Integral from what?
X to x squared.
X to x squared.
From the integral from 0 to the natural log of z.
LNZ? Is that what you said? Okay.
Of x e to the y. dy, dz, dx.
Okay.
And what's funny about this one is I was close to getting it right on the test, and I haven't ever seen it.
Right. This is triple integrals, which is the last thing probably we'll get to do in Cal 3. Yeah. Okay. Now, since these are all multiplied, you're going to be able to do it the way I'm going to do now. Okay. The first thing is verify we've got the order right. Okay. And you do the innermost, then the next, and then the next.
And since you have a y in the original, that's right.
Okay. This is certainly doable.
Right.
And you'll get a z when you evaluate it.
So
And
that
then
would
you
be
certainly
z.
can do that. You'll get an x, another x when you evaluate it, and then you'll do this on x. So yeah, your order is right.
And that's like the first thing I saw. You know, it's like this matches up, so that kind of makes sense.
Yeah, okay.
But you got to do partials, right?
It's like that, okay. It'll make it easier to see. So when you're integrating with respect to y, you treat the x as if it's a constant. Okay, and there's no z's in there, so basically what you could do is move the x out here because it's not doing it. But you see that's then with respect to z, so then you could even move it as far as out there, and that might make it easier to look at. Because the integral with respect to x is the last one you do, so put it with that. Okay. And this will make that easier to do then.
It looks like it make it easier.
Yeah, so you start and do that integral first. And what is that one?
Okay, so that would be e to the y.
E to the y.
From 0 to natural log of z.
Okay. And that would be integral from 0 to 1, x, integral from x to x squared.
So it'd be that would be e to the natural log of z minus 1.
Okay, yeah, but what is e to the natural log of z? Z, okay. So that would be a z minus 1. Okay?
This is looking really simple.
dz, okay? Then a dx, okay?
Okay.
Now you do that one. Now, there's nothing to separate here because it's plus or minus. You can separate products and quotients, but not here. That'll be the integral from 0 to 1, x. And what will that integration be? Z squared over 2 minus z evaluated from x to x squared dx. So this will be
X to the 4th. Oh, you want to write it all out. So 0 to 1.
no. Okay. However you want it to, but yeah.
X
And the
times
x is there. Okay.
whatever.
And what will be in here?
X to the 4th over x squared.
Over 2. That's a 2 down there.
Oh, it's a 2.
Yeah. See, it's not slashed. Okay. Never mind.
Yeah,
Okay. Right.
Oh, it's a curl.
Yeah.
Okay. I guess you do too. It's just hard to see. Okay.
Yeah.
So,
Minus
x squared
x squared minus
x squared over 2
x squared over 2.
minus x.
That'll be then a plus, right? Minus a minus.
Have it distributed to the negative.
Oh, okay. You're putting that in here yet. Okay.
Yeah,
Okay, got it.
I do my.
Right.
It almost looks like I'm trying to factor.
Yeah, okay. Yeah, that would be a minus then. Okay. I couldn't hear your parentheses. Okay. And what was the last?
There weren't quotes.
Okay, x. Right?
X minus x.
Okay. And then we'll ultimately have a dx there, but we got a little bit of stuff to do before we get there. So this will be, I'm going to come up here. Okay. Integral from 0 to 1 of x times x fourth. Yuck! This thing aggravates me. Okay. I know. No, over 2.
Oh yeah.
The thing slid and I put it in the wrong place and it just was a mess. Okay. So let's get that back. Okay. That's an x fourth over 2. Now, you have a minus x squared over x squared and another minus x squared over 2. So that first x squared is a minus 2x squared over 2. Minus x squared over 2, that would be minus...
Wouldn't it be minus a 3x squared over 2?
That's exactly what it is. Okay?
Plus x?
Plus x.
Now we can distribute our x out.
Yes, and this would be integral from 0 to 1 of x to the 5th over 2.
Minus 3x to the 3rd over 2.
No, x squared. Isn't it? Oh, no, I'm sorry. We're distributing. I'm sorry. I thought you were integrating already. Okay, got it. Over 2. Got it.
Plus x squared.
X squared. Now we integrate. Okay, I hope I can erase that. Well, let's see if I can squeeze it in. 0 to 1.
Oh, I thought we were
Wait, yeah, just integrate. Yeah.
Okay. So that would be x to the 6th, right?
Mm-hmm.
Over 10?
Over 12.
Over 12, sorry, yeah.
Yeah.
Minus x to the 4th.
Okay, you got a 3x to the 4th over 8.
Plus x cubed over 3.
Evaluated from 0 to 1. All right, we'll come down here and do that. No, we won't. Let's try it.
And we pretty much forget the 0 part.
I've done it already. Okay. Okay.
And that would be 1/12
1/12.
minus 3/8
Got it.
plus 1/3.
Yuck. Okay. Now, least common denominator.
40?
How about 24? 24? Okay.
Skip right over.
Okay. That would be 2 24ths minus
9/24?
9/24,
plus
8/24.
so that'd be 1/24.
1/24. Is that an answer?
That's what they got.
Good for them. All that for that little fraction.
I
Okay.
know. It's like so simple.
Yeah.
Just never saw it coming. Okay, and I learned how to pick.
Okay. Can I erase all that?
Sure.
Okay. Which is this, 25 now or what?
25.
25. Okay.
Oh, sorry.
Okay.
I'm waiting. All right. So this is a piecewise defined function.
Okay.
F of x. And then we'll start off with x, absolute value of x.
Absolute value of x?
Yeah, it's piecewise defined.
Right. I got it. Yeah. I was waiting to see how many before I put it in. 3. Okay.
And then across from that is x less than or equal to -2.
Okay.
Okay, below that is ax plus b
ax plus b.
is -2 less than x less than or equal to 4. Below that, 3x squared plus 2 is x greater than equal to 4.
No, one of those equals to and one not, but it doesn't matter.
Well, that's equal to.
And the middle one is,
The middle one's right. The bottom one needs a greater than or equal to me.
okay. Okay. But you see, if that's less than or equal to, and this is greater than or equal to, then both the fours are in both groups.
Yeah.
Okay. And that's why it is on there. Okay. Unless that's the same value, this is not a function. Okay. Let's see it. Well, let's see what. Go on with it.
Well,
Okay. It's all right.
What they want you to see is
Yeah.
find values for a and b, so it's continuous.
So it's continuous. Okay.
So you
Right.
find where it is.
So it is a function. Okay. I hadn't heard the rest of it, but I said maybe it will be okay. All right.
Okay, so we need to find where I think
All it needs is continuity, right?
Continuity.
Okay, yeah. So basically what we have to have is this thing has to equal what this thing at x equal -2. And of course, f of -2 is equal to 2. So then we have to have that that is ax plus b is equal to 2. Oh, a of -2. Okay, right? When x equal -2, it's got to be 2.
right.
Okay, so that says that minus 2a plus b equal 2. Okay. No. Yeah, that's right. Yeah, that's right. Okay. And then the last one says, okay. Next, well, the last one says that f of 4 is equal to
3, 4 squared plus 2.
which is equal to
16 times 3. 8, 1, 48. 48 plus 2 is 50.
okay. So this also says that a times 4 plus b is equal to 50. Right?
Right.
Okay. So 4a plus b is equal to 50. All right. What might you want to do to solve those two equations simultaneously?
Eliminate these.
Okay. How?
Flip the signs of one and then add it to the other.
Okay. Make that plus, minus, minus. Okay. And add those two together, and what do you get? 6a is equal to, say again?
52.
Yeah, say again.
48.
48. Good deal. Okay. And then,
I think I messed up the signs.
yeah.
48, and that would be a equals 8.
Okay, got it?
So plug back in.
Let's go back to the first one. Minus 2a plus b is equal to 2. That was that first one, right? And that would be minus 16 plus b is equal to 2. B is equal to 18. So a is equal to 8, b is equal to 18.
And that's what they got.
Good for them. All right. Okay.
Would it be horrible if we wrapped it up here so I could at least swing by Scholars Bowl beforehand?
Okay, absolutely. All right, we will end it.